Grab a marker or a pen, and let's see how you did. Farmer would like to create an enclosure with 3 equal parcels. This, by the way, only works if the parcels or the sections are equal. All of them have to be equal, or else this doesn't work. He has 900 feet of fencing available. A diagram of such enclosure has been provided below, which is usually, I would consider this as part marks, right? But you basically want, right, obviously the longer sides, we call them length. And you're making 3 enclosures, but if you think of the lines, there's width, 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 right? So the width of this big rectangle, you're gonna need 4 of those to make this enclosure. Okay, so that's very important. So you end up with the perimeter being 2 times length plus 4W, right? 4 widths. And the perimeter is what we consider the fencing. That's what we have available to make this thing. So we go 900 is 2L plus 4W. Now, at this point, you have a choice. You can either isolate L. I don't know if in the video I said that, but you can isolate length or width. It's up to you. I've already given you the widths that I want you to plug into this. So this is technically my independent variable. I've told you that, which means that length is the dependent variable. So I want length to be isolated. Okay. So you can grab this and just go 900. The 4W when it comes over would subtract, and that's equal to 2 length. And then at this point you have to divide both sides by 2. Right? And then so length is equal to 900 minus 4W divided by 2. You can divide both by 2 if you want, and so the most simplified expression would be this. I would accept this because there's nothing wrong with this expression. They're both saying the exact same thing. So if you have that, you get a mark for that. If you isolated W, then it's 900 minus 2L divided by 4, which is a problem in this case because I'm giving you what the widths are that I want you to plug in. We're essentially finding points, right? We're finding our 3 points with this table. So using this, so on my study sheet, I would always be like, create a little diagram, label L and W, then create this. This is how much fencing is available, or line, or whatever. Then isolate for either L or W, right? You decide. And then you come up with your table. So my table, if W is 50, so I'm using this over and over, the length would therefore be 450 minus 2 times 50. So we know that 2 times 50 is 100. So technically, this is 350. You should always be able to double check and see if this makes sense. So let's do a mental math exercise here. If the widths are all 50, so that would be 50, 50, 50, 50. That's already 200. That's 200 just for the widths here. So that means that these two should add up to 700, and it does, right? 350 and 350 is 700, plus the 200 is 900. So you should be able to go back and see, like, if I were to use these dimensions, do I get the 900 total? And I do. So the area is 350 times 50. I'll fill that in later. Now, what if my widths are 100? So then it's 450 minus 2 times 100. Sorry. So this is 200, so that would be 250. 250 times 100 is the area that would result if I use those dimensions. 150, so that'd be 450 minus 2 times 150. 2 times 150, we know it's 300. So 450 minus 300 is 150. 150 times 150 is what the area would be here. I would give you a mark for this table. Like, let's say you made a mistake up here, you would lose this mark. But if I see you using this to come up with the lengths, then technically I would give you the mark for filling this out based on your equation up here. So let's enter this into our calculator. What is it asking? Determine the equation that relates the length and the area. So these two. I need the area anyways. So I'm going to go ahead and type that into L1 and L2. I'm going to clear everything. So it'll be 350, 250, 150. And this will be 350 times 50. That's 17,500. 25,000. 22,500. So I'm going to write that in. And this is square feet in this case for the area. So I give you 1 mark if this is completely filled in. And so for length is L1, area is L2, right? I'm making that note here. So I need something here. Something quadratic or a few buttons that you're pressing to get there. So I'm going to go ahead and perform my regression. Stat, calc, quadratic regression, second 1, comma, second 2, comma, alpha, trace, y1, and there it is, negative 0.5x squared plus 225x, and it's a minus. These ones, to be honest, they should always be pointing down, right? You shouldn't have one pointing up. And of course, your quadratic equation would be different if you're, so it's kind of like a bad carry on, right? Like this will affect that, which will in turn affect this. So today we're just going to assume you didn't mess up on the part where you have to put these one into L1 and L2, unless you know for sure you went and put the width into L1, then you're in trouble. But if you actually entered these values into your calculator, whatever you get here, I would still give you a step mark, right? Step mark. Maximum area. Well, let's first get this on our screen. Let's see if I can make it work. So I'm going to go graph. Doesn't work very well for me, but I know where it's going. So I'm just going to stick with my window here. X max, I may increase it to, let's say, 200 for now. My Y max, I'm on the 22,000s, 25,000. So I'm going to go 35,000 for my Y max. See if that works. So the height, the Y max works. The X max is still needs to go far away. So I'm going to go, I don't know, 900. That's pretty good. So this is a pretty good window here. So I'm going to find the maximum area. The maximum area will be found at the vertex. So we're going to go second trace maximum. And you got to go to the left of it, then to the right. Enter, enter. So we're going to go second trace max. That should give it away that if yours is pointing up, you don't have a max, you only have a min, right? So maybe try to find ways to get you back into the game. Oh, this is actually 225, right? If you round it, 25, 312.5. So the maximum area is this, right? The Y value, and this is square feet, is the maximum area. Okay, so I need to make sure to get full marks, you need to tell me which one of these is the maximum area and the units, okay? CD, this one, what dimensions would result in the maximum area? Now dimensions will be your length and your width. The length, I already know it's 225 because I know that all the x values represent my length. So that's 225 feet. To get the width, honestly, all you have to do is area divided by length. So you take this area divided by 225, and that's what's going to give you your width. That is 112.5 feet. So these dimensions here, using a length of 225 and a width of 112.5, if you use that, you would get the most out of your fencing. The biggest area for every enclosure. Okay. That's how this works. So I give you, I guess we can give you 1 mark for this, even though there should be a bit more, but we're just going to give you 1 mark for each. So that's 112. And again, if you were to plug this in, let's go back to this one. If you were to plug in the length and the width that you just found here, right, you should get 900. Okay. State the domain and range. I need to do a little bit of work here, perhaps. I need to first find the intercepts. How about I graph this first? So this would be area in square feet. This should be length in feet. So I need all my intercepts. The vertex I already have. So I know this is 0, 0 here because there's a C is 0, so the y-intercept is 0, 0. We know that. So is the x-intercept. So let's find the x-intercept over on the right side. So I can trace 5. I'm going to find this one on the right side. That's 450, 0. Okay. So I will x-intercepts. I have 0, 0 and 450, 0. I use y2 is equal to 0, second trace 5, right, to find that. So that's going to help me set up my scale here. I'm going to go 100, 200, 300, 400, 500. Okay, like that. And here I need to go all the way to 25,000 something. So let's see, 10, 20, 30. Can I do something else here? 5, 10, 15, 20, 25. I could do that as well, but then I'm a little off. That's okay. It's a 0, 0. 450 is right in between. And then I've got 225. This is 250 right here. 225 would be right in the middle, all the way to just over that 25,000 mark right there. And so your graph would look like that. This is that's my equation. So I have labels, scale, shape, all that would be 2 marks. And you might wonder, why did you do the graph before the domain? Because I like to see my domain are the x values, and it goes from 0 to 450. Can't have a negative area, so it stops here. Okay, so it goes from 0 to 2 to 450. After that, you have a negative area. The range, you go from 0, right? 0 all the way to the top. The greatest area is the y value of the vertex, which is right there. So you would get 1 mark for each of those entries right there. Is that small or what? Try. So I would say, if you made a mistake only way upstream and everything else kind of follows this, you kind of have the same method, you get still 9 out of 10. But if you have made additional mistakes along the way, then you take off more as you go by, right? As you go through this. So at the very top, just make sure your name and last name is on there and your mark out of 10. And I'll take these in, give them back to you. You know what? You were asking me for study sheet entries. Everybody has their own way of doing this. So maybe on the back of this, I would just do type 2 fencing. I would have something like that. I'm going to give this back to you. But I would just say sketch, enclosure. I would say the watch, 4 sides, not needing. Not requiring, not needing fencing. Okay, I don't know if, I'm pretty sure I covered that in the video, right? Like where sometimes you build it, you make an enclosure next to a barn or next to something that doesn't require fencing, then your formula for perimeter will change a little bit. So example, I'm just gonna say, I would have an example like this. I've got, right, length, width. That would be step 1. And I'd say fencing is equal to 2L plus 3W. That'd be step 2. Like your diagram translated to an equation like this. Isolate the independent variable. So I'll say example, if you wanted length to be isolated, then it's Monday. Isolate the dependent variable. Okay, the one that's isolated depends on the other, whatever the other one is. So not independent, the dependent. Isolate the dependent variable. So length would be fencing, I'm just going to use F, minus 3W over 2, or W, width here, would be fencing minus 2L, and then you got to divide by 3 at the end. Okay. If you isolate for L, then you pick 3 values for W. And in this case, pick 3 values for length. You can go 1, 2, 3, you can go 10, 20, 30, you can go 100, 200, 300. It doesn't matter. It doesn't matter. You just pick. And then the last one is table, where you go length, width, area, and maybe just tell yourself that area is length times width. Okay, you're gonna make your study sheet a lot more compact, but I will say this. If you isolate L, right? If it's L that is isolated, then you got to pick three values for W. So that'd be 10, 20, 30, or if you isolate for W, you got to pick three values for length. So I'm gonna make this really messy here. So this one is that, and this one goes for that. I don't think you should use up that much space. 99% of the time, my table will be partially filled in like I did on this AC. And the main reason is because it's a bit of a nightmare to market if everybody picks their own things, right? Like their own values. Like I don't know where you made a mistake if you do make a mistake. So I tend to just give you the values, which means you have to know what to isolate for. Probably the least favorite of all the types. Type 0, I give you all the points. You just plug in and go. Type 1, it's the profit revenue, right? Like if something goes up in price, you'll sell fewer, right? That kind of scenario. It's kind of easy to come up with your points. Type 2 is fencing. And then type 3 is the story, right? Where you start somewhere, you jump up, and then you have to use the symmetry of the parabola to find your third point. Okay. All right. Uh, that's it for this AC. I'm going to stop right here.